Hi students, so now let us discuss about the non-linear partial differential equations. Okay, so non-linear partial differential equations. What is a non-linear partial differential equation? Okay, so a partial differential equation which involves the first order partial derivatives. Okay, remember the first order partial derivatives p and q. Okay, p and q with a degree higher than 1. Okay, so the degree, if the p and q degree is having 1, then they are known as the linear partial differential equations. Okay, other than 1, if we have, they are known as a non-linear partial differential equation. And of course, not only the degree of p and q other than 1, and the products of p and q. Okay, and the products of p and q is called, if the products of p and q is also contains in the equations, then also we can call it's a non-linear partial differential equation. For example, these are p square plus q square is equal to pq. Okay, p square plus q square is equal to pq, and the degree of p and q, it's not 1. Okay, it's other than that, so it's p square q square. If the equation like p plus q is equal to pq, if we have, okay, p plus q is equal to pq if we have, so that is also non-linear. Why? Because the product of pq we have, so since product of pq we have, so that is also non-linear. And another example like here, p square plus pq is equal to z square, and another one, z square into p square x square plus q square is equal to 1. So these are the some examples of non-linear partial differential equations. So in the non-linear we have, okay, so we have standard types, actually 4 main types of non-linear, actually here 4 actually here standard types of non-linear partial differential equations. Okay, 4 equations we have. So actually here I mentioned 6. So these are the transformations. Actually these are can be solved by using transformation. That means the 5th and the 6th are solved by transforming into 1st, 2nd, 3rd. Okay, transforming these 5th and the 6th by transforming into the 1st or 2nd or the 3rd, we'll try to solve. But the main standard types of non-linear equations are 4. Those are type 1, that is f of pq is equal to 0. Type 2, f of zpq is equal to 0. Type 3 is f1 of x comma p is equal to f2 of y comma q. The last one, type 4, z is equal to px plus qy plus f of pq. So these are the 4 standard types, and this 5th and the 6th we'll try to solve by transforming into the type 1 or type 2 or type 3. We'll try to solve them, okay, by using the transformations. Yeah, so what is the first? F of pq is equal to 0 means the equations contains only p and q. Okay, the equations contains only pq. Okay, pq's, nothing there, nothing like x, y, z. It doesn't contain anything like x, y, z. Only contains p and q in this. Okay, so let us discuss how to solve the first type 1 problems. Okay, so this is the standard form 1 here. Standard form 1. Equations of the form f of pq is equal to 0. That is equations containing only p and q. Okay, so in this case, how to solve this? Let the required solutions be. Let the required solution be. So we'll try to assume the solution before we'll starting the problem. That's by like this. If the equation, the standard form is 1. Okay, then we'll try to go with z is equal to x plus by plus c. Let the solution be like this, 1. Now if I differentiate this equation 1 partial with respect to x, what happens? Dou z by dou x is equal to a, dou z by dou y is equal to b. Okay, now substituting the above value, these two. So this is p and this is q actually. Okay, this is p and this is q. Substituting the values in the f of pq is equal to 0. Okay, we get f of ab is equal to 0. Now from this, okay, from this 2, what we can have, b is equal to b in terms of a you will get. Okay, b in terms of a is equal. Then the required solution will be here. Z is equal to ax plus phi of a y plus c. So this is the required solution. This is how you will get here. Okay, by in the standard form 1. Why? Because in the functions, elimination of functions, we already discussed, if the partial derivative is of first order, then it must have only two arbitrary constants. Okay, so here you can see a and c, two arbitrary constants, then only the required partial differential is of the order 1. Okay, so now let us do one problem here. Solve. Okay, problems here. Solve p plus q is equal to pq. P plus q is equal to pq. See here, it's a nonlinear equation. So p plus q is equal to pq. Let the required solution be z is equal to x plus by plus c, and p is equal to a and q is equal to b. Substituting in 1 we get substituting in 1 we get, so what I'll get here, this is what I'll get. A plus b is equal to ab. A plus b is equal to ab. Now from this, b into a minus 1 is equal to a, b is equal to a by a minus 1. Substituting 3 in 2, we get z is equal to x plus a by a minus 1 into y plus. So this is the required solution, and this is how we can solve any non-linear equations of the standard type 1 can be solved in this way. Okay, if the equations contains only p and q, okay, equation only contains p and q, not contains z, x, y. Okay, only p and q, some other constants also it can contain. So it can be solved by using this way. Okay, so this is the standard form 1 of nonlinear types. Okay, thank you.